So in this section, we are going to discuss about the suppress-arp feature. Okay, so suppress-arp feature will be used with the BGP VPN to limit the broadcast. So for example, let's say host 1 is trying to communicate. Let me delete these information. Just give me 1 minute. So let's say that leaf 3 and leaf 4, they are having host 1 and host 3, and they are communicating with each other. So leaf 3 is going to populate the information about host 1, the IP address 10.1.1.3 and the MAC 1111 into the BGP EVPN update, right? So into the BGP EVPN update, leaf 4 and leaf 5, they are going to receive the information about 10.1.1.3 and its MAC address, correct? So likewise, leaf 5 also it will receive the information. Likewise, leaf 4 is going to send the information about host 3, the IP and MAC into the BGP VPN update. So both leaf 3 and leaf 5, they are going to receive this information 10.1.1.4, MAC 3333. So here, now let's say that host 5 wants to communicate with host 3. Okay, now what will happen in this situation? If we do not have suppress-arp features, then host 5 is going to send the ARP request because it does not know about host 3. So leaf 5 will receive the ARP request and it will consider it as a bump traffic, and using the method that we are running into our underlay, maybe we are running the multicast, or maybe we are running the ingress replication. So using that, those bump traffic handling techniques, it is going to send this particular bump traffic to the respective leaf switches, or in our case, the leaf 3 and leaf 4, right? But you can see that though leaf 5 knows about the IP to MAC binding that host 5 is looking for, which is 10.1.1.3 and 1.1.1, right? Still, it will consider it as a bump traffic and it will take the necessary action. But if suppress-arp feature is enabled, then when host 5 send the ARP request to find out the MAC address against the IP 10.1.1.3, leaf 5 is going to open this particular ARP request. It will check that what exactly host 5 is looking for. Now it will see that, okay, leaf or host 5 is looking for the IP to MAC binding, right? Or in particular, the MAC address against the IP address 10.1.1.3. So leaf 5 is going to take help from the control plane or BGP control plane to ask for if it has this particular binding. And yes, it has, right? Because it received 10.1.1.3 and 1111 into the BGP VPN update. So leaf 5 on behalf of host 3, it will directly send the ARP reply. Okay, something like that. For example, host 5 send this ARP request, source IP and destination IP, source MAC, and it is looking for the destination MAC, right? So this particular ARP request, when received by leaf 5, so now leaf 5 on behalf of host 3, it is going to send a ARP reply directly to host 5, something like that. 10.1 source IP will be 3, 10.1.1.3. So it will behave like host 3. So directly it is going to send the ARP reply source IP, destination IP, source MAC 1111, destination MAC 5555. Now you can see that host 5 received the MAC address against the IP address 10.1.1.3. So this is how the suppress feature helps us to reduce the broadcast into our network. And it is very easy to configure. I'll show you the configuration. Simple configuration. You'll go to the interface NVE1. You'll go under the VNI. Let's say this is VNI for VLAN 10, and you will just say Suppress-arp. That's it. Similarly, you can do it for, let's say, member VNI 2020 Suppress-arp. That's it. Single command you need to configure for the Suppress-arp feature. So I hope that now you are familiar with this particular feature, and see you in the next section. Thanks for watching.